Hello, and welcome to another episode of the STEM Brothers Podcast. I am Kwesi Vincent.
And I'm Basir Vincent.
And we are the STEM Brothers. Thank you and welcome. Thank you for joining us on this episode. This is episode 7, Basir.
Absolutely. They keep coming, and we're getting a lot of great guests and having a lot of good conversations.
Absolutely, and getting a lot of great feedback. Want to thank everyone who's listened to us from the beginning. If you've gone back and listened to episode 1 and 1 through 6, hopefully you've gotten a sense of what we're trying to do here. We are gradually building what we hope is a very valuable knowledge base and teaching tool that can be used in the area of science, technology, engineering, and mathematics education, as well as career development. And I won't go into the purpose of the podcast again, because I think I've reiterated it in prior episodes, but if you're joining us for the first time, just know that this is the general idea of what we're trying to do is to bring forth examples of how science, technology, engineering, and math affect our everyday lives. So, go ahead, Basir.
The technology is all around us. We're seeing all the things that happen. And last week we introduced the idea of the Internet of Things. And we had my close friend Larry Murray, who is a network engineer, and he talked about how he, at his work, dealt with this very basic, or what seemingly a more basic concept of the Internet of Things. It's a series of devices connected by a network that you can control. The examples we gave last week were a thermostat and potentially a fridge and light bulbs. And this work is done at a place of business such as Penn State University, where Larry Murray works. And he was responsible for creating the network. So the road or the pathway between the devices is the best layman's way to describe a little bit, just the tip of the iceberg of what a network engineer would do.
Correct. And that's a great summary. If you haven't listened to episode 6 of our podcast, we both strongly encourage you to go back, listen to that episode, because our guest Larry, he gave some great insight and some great background into what a network engineer does. And actually, our conversation from last week was the inspiration for the topic that we cover in this week's episode of the STEM Brothers Podcast. One of the things that, as Basir mentioned, the key implementation of the networks that Larry designs, maintains, and builds at Penn State, they're the networks that the automated building systems for the various buildings at Penn State, this is the information technology network that those systems are controlled by and monitored from. So the systems that allow the security of the building, so the automation of the locks, cameras, things like that, alarm systems, all of that is controlled and monitored over an IT network. And this is a network that Larry designs and maintains, right? The lighting, the environmental controls, the heating, ventilation, and air conditioning and such. These are all things that are connected and send different signals back and forth across a data network, and a network such as the ones that Larry described in his conversation with us last week. So that really got us thinking about the whole idea of building automation systems and just how this idea of the Internet of Things, how far along is it going to advance what we know, what we find today in our homes and in the buildings that we work in and go to school in and things like that. We see a rise, an increase in the automation of buildings. And one of the articles that I found that was pretty interesting, just to illustrate, the growth of the overall building automation systems market, is I found an article in a financial publication that talked about the market. The building automation systems market is worldwide is $94 billion in 2015.
Wow, $94 billion. That's billion with a B.
Yes. This includes all aspects of the whole building automation ecosystem, the hardware, the software, different aspects of the infrastructure piece of designing and building a building that is a smart building, right? A building that has various electronic components to it that can be controlled and automated remotely. So, and this market is expected to grow to over $116 billion by 2020.
Wow. Right. And a big reason why this market is growing is it's saving people money as well. Through the cost of these things, you can save as much as 30%, but all the way up to 50 and 60%, depending on how much work you put in to a building. You're getting that much energy savings by integrating these just devices and beginning to thinking about regular things like turning on and off lights in a smarter way.
Absolutely. As the need and the requirement for our homes and our office buildings and such, as the requirement for these buildings and homes to become more energy efficient. These are requirements now that the government is mandating. As the requirements for these energy efficiency improvements increases, so will the automation of these buildings. There is, instead of someone having to manually turn off the heat or turn off air conditioning in order to not waste energy, the homes and buildings will now have different sensors to know when someone's in a room, when they're not, or all these things will be able to be controlled if it is a person controlling them and it's not just on automatic pilot. There's somebody who will be controlling these and doing these things remotely. We'll get into more of that later in the episode, as our guest will talk about. Matter of fact, let me set up who our guest is with this. So what we wanted to do is bring on someone who could talk about how this rise in automation is affecting buildings today and how it's going to affect the buildings and homes of the future. So we had the opportunity to speak with a good friend of mine this week, Mr. Damian Payne. Damian is a longtime friend of mine, graduate also of Penn State University. Damian is a senior associate at Joseph R. Loring and Associates. It's an engineering firm in New York City. And Damian has a lot of knowledge, and I'll allow him to give you more about his background. But we had a great conversation with Damian, and we think it's a perfect segue from our topic last week and our conversation last week about what network engineers do. So last week you got a chance, or last episode you got a chance to hear the person who is who's building, maintaining, and designing the roads, right, the highways and all that kind of stuff. Now we'll get a chance to hear from one of the individuals who's involved with building and designing the cars that are that need to ride on the road, for lack of a better term, right? Or to continue with the analogy from last week or from last episode. So what we hope is that the tying together episode 6, the previous episode, with our conversation with this episode, you begin to see the whole picture of how the concept of the Internet of Things is becoming more and more prevalent every day, and how it all interconnects in the various career opportunities that will exist in this whole entire ecosystem of the Internet of Things. All right. So, go ahead, Basir. I'm sorry.
No, I said yeah, and it's a great pairing with the previous episode, and we hope you listeners get a chance to see how all these things are connected, or find interest in one thing or another. You might not be interested in how the roads are laid down, but understanding how that works, you might find more interest in the vehicles that are on that road. And it's a very interesting discussion.
Absolutely. So, without further ado, one last thing. Again, the whole purpose of this podcast is to provide. We view this as an educational tool. We hope that parents and teachers and individual students themselves will find this information helpful in becoming more informed about career opportunities in STEM, find new and different ways to teach science, technology, engineering, and math, the various concepts within those disciplines. Hopefully the information we share by bringing to light these different everyday applications of science, technology, engineering, and math, by having these discussions, it begins to normalize these concepts, and therefore helps increase retention and interest in the science, technology, engineering, and math related fields. So with that said, if you have an interest in learning more about what we do in our work, if you're interested in bringing us in to do some workshops or some programming for your young people, or for perhaps your group of career changers, or anyone who may be interested in learning more about opportunities in science, technology, engineering, and math, please contact us at stembros@gmail.com. That's STEMBROS@gmail.com. And now, without further ado, our conversation with Mr. Damian Payne. And welcome back. As promised, on the line with us, we have my good friend, Mr. Damian Payne. Damian, how's it going?
Good. How's everything going tonight?
Everything's going very well, very well. Thank you for taking the time out to talk with us and join us on this episode of our podcast.
Thank you for the invitation.
And so I wanted to start off our conversation with you giving a brief explanation of what the major architectural engineering is in your own words, and what your experiences sort of taught you about that major. And then also, if you could get into what various certifications you hold, and then what do those mean?
Sure, not a problem. So The architectural engineering program at Penn State is a unique program. It's a 5-year program, which is similar to most architecture programs. But the difference and the uniqueness of this program is that it's focused on the engineering component of construction. So part of our curriculum, we would take various courses in different aspects of engineering and constructing of a building. We would take electrical classes, we would take HVAC classes, which stands for heating, ventilating, and air conditioning. We would take structural classes, and we would also take construction management classes. So it would give us a very well-rounded background for all the different aspects that are associated with constructing a building. Also, part of our 5th year, we would also take a studio with the architecture students, so we would learn how to work as a team in a collaborative session, because when you are in the real world, that is probably one of the most important things, is getting used to and having the ability to work with different individuals that come to a particular problem with a different expertise and working together to create a building. I mean, that is the end result, and that is the goal, that we make someone's someone's dream come into a reality.
How long have you been working in the architectural engineering field now?
So I graduated from Penn State December of 2000, and I've been working full-time for approximately 15 years in the MEP consulting realm, where I'm a HVAC mechanical engineer. While I was in school, I had multiple internships. I had internships with Con Edison. I've had internships with Office of Physical Plant, which is the in-house engineering department of Penn State. And also I had 2 internships, summer internships with Lauren Consulting Engineers, which is the same MEP consulting firm that I then started my full-time career with, and I am still with today, and now presently a vice president.
And so you have obviously gone on to continue your learning beyond the undergraduate training that you received at Penn State, and that's resulted in you being certified in a couple different areas. Can you go through some of those and what they mean about your professional knowledge?
Sure. So probably the most important certification for an engineer in the consulting business is your PE, which stands for professional engineer. There's actually 2 components of that exam. The first one is called the EIT, which is your engineering and training. They've actually renamed it a number of years ago to be FE, which is fundamentals in engineering. What that is that's a test of your knowledge of your undergrad studies. So you can actually take that test while you're still in school, and that's the first part of it. Then the second part is your PE, which is the professional engineering, and you have to have a 3 to 4 years of professional experience prior to taking that exam. So the idea there is that you're actually learning hands-on what it is to be a true professional engineer, and then an exam that tests some of that knowledge that you've obtained while in the workforce. So that is by and far the most important one. But there are other certifications that have, based on how the industry has evolved, there are other certifications that, depending on how you want your career to evolve, are also beneficial. One of them being the LEED certification, LEED standing for Leadership in Energy and Environmental Design. It's the new buzzword. I'm sure if you've walked into any of the new buildings, you'll see a LEED plaque. That particular certification helps you learn the actual certification process in order to get a building LEED certified. It's an important process because it shows that the design team and the owner and the contractor is taking onus on creating a building that is energy efficient. And there's a number of different ways to get different certification levels. They have ones that's certified, bronze, silver, gold, and platinum being the best and considered the most energy efficient. The other certifications that I have are the CEM, which is a Certified Energy Manager. That one is with respect to helping an owner or a an owner or a developer have a better understanding of different components of their building with respect to energy use, and helping them have a better understanding on how to operate their building so they're saving money across the board. The last certification that I have is my Certified Building Commissioning Professional. Commissioning is something that has definitely come into the forefront in the last 5 to 10 years. Commissioning is basically going point by point with respect to a control system, an HVAC system, an electrical system, and actually making sure and verifying how the building is actually operating. This information is very, very important because you can design a building one way, but it might get built and operated totally differently. So this is really to get a better feel for how the building is actually operating and how it's actually working, and using that knowledge to then tweak the building and actually change its operating schedules and in order to operate the building more efficiently, and also decrease on the number of different complaints that you may get from the occupants.
Awesome. You've mentioned HVAC a couple of times. Just for our listeners, can you give a brief explanation of what that is?
Sure. So HVAC is just an acronym that means heating, ventilating, and air conditioning. So and we go one by one. So heating. So it's the design of all the heating systems associated with the building. Some are steam, some are hot water. Ventilating, that stands for your outside air, the air bringing from outside into the building. Back in the 70s, you had the sick building syndrome because one of the ways they tried to save energy was to make buildings extremely tight, and they realized that when you don't have fresh air coming into the building, some of the occupants get sick. And then AC stands for air conditioning. So now providing air conditioning for the actual building so you're cool and comfortable during the spring and summer months.
Clearly, you have a lot of knowledge and experience about buildings, and I wanted to establish that at the start of our conversation because one of the things that we wanted to talk to you about today is we see a lot of advancement with the idea of smart buildings, quote unquote. These lots of automated systems, different things like that, all connected by these networks, these information technology networks, so that different systems can communicate and buildings can be operated essentially remotely or automatically. And I wanted to talk to you about the changes you're seeing in the industry and in your work, and what these advancements have meant for your profession.
Sure. What's interesting is that a lot of these ideas aren't new. One of the main things that occurred years ago was a building management system, which is the acronym BMS. So basically what that was is a control system that operated the building automatically. Now, when they first started, obviously, just like when you had your first computer, and I'm dating myself here, a Commodore 64 or a Tandy 1000, they were very rudimentary and they weren't able to do much without a lot of programming. But now with the advances in all of the technology that is out there now with respect to apps, tablets, smartphones, there are definitely more programs and more advances with respect to how the building management system could actually tie into multiple components of the building. Initially, your BMS system was there to control the HVAC system, so your cooling and your heating for the actual building. And basically what it was doing was it was controlling an air handling unit or a boiler or a chiller, and based on how you changed your thermostat, it would then change multiple pieces of equipment in order to meet that set point on the thermostat. With the advances in technology, now the BMS system has the ability to connect multiple systems. So you have things like a daylighting system where you have the ability to reduce the amount of artificial light within a building based on the sun and the amount of light that's coming into the building. You have the ability to connect your security system, so all your cameras. You have the ability to connect your domestic hot water system. So if you have a large locker room or you have lots of bathrooms, you have the ability to understand how much water you're actually using or wasting. You have the ability to have automatic shades now. There are definitely advances where you have the ability to really automate almost every function of the building, which is very good because it gives you the ability to have understanding of how the building's actually operating. With the technology now, you have the ability to have real-time feedback on how a building's actually operating. You could see temperature trends throughout a building and throughout the day. So, for instance, you could see how at a particular point in time of the day, maybe it's 8 o'clock, 9 o'clock, when everyone is first coming into your office, how you have a spike in temperature. So because of that, if you understand that you have a lot of individuals or occupants come into the building at that time, you may have the ability to pre-cool the building in the summertime or preheat it in the wintertime. If you notice that all your occupants are leaving at 5 o'clock, then you could do energy saving protocols where instead of having your thermostat set at a typical comfortable temperature of, say, 75 degrees, you could raise that temperature slightly, say 76, 77, 78 degrees in the summertime when there's no occupants within the space. Obviously, there's different caveats depending on humidity and what type of materials you have in the space. If, say, for instance, it was a library that had rare artwork or something along those lines, you will have a little bit less flexibility. But it does give you the ability to change your set points and have the ability to save energy that way. It's similar to a programmable thermostat that you would have in your house, but just a more robust version of it that has the ability to control multiple systems.
How does the fact that these systems are now going to be automated impact the design process of a building? What sort of...
So one of the first questions is you always have to take a step back and have an understanding of what the owner is looking for before you design. Some owners have the capability where they have the staff to actually operate a building and operate a building that has high-end technology. Some owners would love to have that technology, but they actually don't have the operational staff that can actually operate the building in that fashion. So one of our jobs is really to get an understanding of what are the capabilities of the owner and what does the owner really want. Because you will deal with multiple types of owners. You'll have some owners who are very knowledgeable about these systems because they've used them in other buildings, and you have others that have heard about it and they're not as knowledgeable about it. So some part of our job is to also explain how these systems actually work. Because at the end of the day, the owner wants the best system for the dollar. It depends on what type of budget the owner has on a particular project. So when you take all those variables, then we start the design process with respect to what the owner can afford and what can the owner actually operate. One of the worst things you could do is design a system that is very highly technical, but then it's operated inefficiently and is operated in a way that it wasn't designed. So then all the energy efficient measures that were designed into it, you're not really taking full account of them. So what ends up happening is from the beginning you end up having a design where based on the goals of the owner, you then formulate your design to go from there. So what we're seeing now is because the owners everyone now has a smartphone, we are definitely seeing a turn where almost all of our systems are fully integrated fully integrated on the HVAC side. And then the question then becomes what other components they want to incorporate into it.
Damian, I love hearing about stories. Can you tell us a little bit about your team? Because this sounds like a lot of different jobs all in one. The operational staff that it takes to design and put together something like this, what does that look like?
So, and it depends on the firm that you're working for, but the firm that I work for is a consulting engineering firm. So we actually do mechanical, electrical, plumbing, fire protection, security, and IT. So we're on the quote unquote MEP side of the team. So what typically your team will look like is a owner. You'll have the architect, and you'll have the MEP consultant, and then you'll have the contractor. So depending on typically a project will come to realization when an owner says, hey, I have this idea, I want this type of building built. They will then go and hire an architect who will then hire an engineer. And then the architect's job is then to now take all the ideas and programs that the owner wants and then formulate it into a 3D buildable model. And then is our job as the MEP consultant then to provide all the infrastructure to allow that building to physically operate. At that point, then the project then goes to a contractor, where the contractor then actually constructs that idea based on plans and specifications. So there are multiple parties within this team, and that's part of the reason why, as I was stating before, in the Penn State program, where we have a group project with the architect, and there's a real focus on working on teams, is that that's the only way that any of these buildings get built, is that there are multiple components, because each of these components, you have a specialty, and then there's different individuals that have those specialties, and all of them have to work together to get to the main goal. So it's a lot of personalities that you're dealing with.
Do you ever interact with the folks who would be implementing the network technology that it takes for all these systems to communicate?
Yeah, so typically what you end up having is that individual is the ATC contractor, which stands for Automatic Temperature Controls. So they're typically they are a contractor where their specialty is the control systems. So what ends up happening is during the design process, we'll have all the different pieces of equipment that we want to control. Then we will speak to a controls vendor, and there's numerous control protocols out there. So we'll speak with one of the vendors and one of their engineers to have a feel for what can their components do. Because just like with computers and smartphones, they're developing new components every day that could do things differently than they did before, better, smaller, faster, etc. So what we will do is we'll have multiple meetings with them, where we will sit down and we'll go over the sequence of operations. So basically how the engineer in their mind feels each piece of equipment will actually physically operate. And at that point, that's when, with the controls vendor and engineer, we will actually come together and write a sequence of operation, which is a word-for-word document that explains how each piece of equipment will work. And from that point, when the documents, the drawings, and the specifications are then compiled, they are then sent to a ATC contractor, who then, at that point, studies all those documents and then creates a physical network on paper on how they feel they can then, all the different components that they would need to actually build and operate this system. And what happens then is they submit those documents to the engineer, and we go back and forth to make sure that all the ideas and all the sequences that we designed into it are interpreted and understood by that contractor before they actually install each component. So we have a hands-on experience with them, going back and forth during the actual submittal phase, and also all through construction, because as construction is going, there'll be different testing that will occur, and based on the testing, there might be tweaks that may have to be changed. There's things such as field conditions, where at one point you thought you could fit a particular piece of equipment in one location, and now you're unable to do it, so you have to find a new location. And then sometimes the owner changes their minds. Sometimes in the middle of the process, one thing that they thought they wanted, they may not want any longer, or now there's a new component or a new piece of the program they want to add. So the process is always evolving until the owner takes ownership of the building or the space when it's completed.
Awesome. Speaking of evolving and kind of next steps, or what's really going to be the next level of this, or what are you excited about future technologies in this field?
So the thing that I'm definitely seeing more and more of, especially with the advent of the smartphone and the tablet, is the ability to have conversations and interact with multiple team members without physically being there, similar to how we're interacting right now via Skype. What we're seeing now is a lot more collaboration via the internet, using GoToMeeting, using Skype, those types of technologies. But the other thing that I'm also seeing more of is more real-time feedback. Real-time feedback of how the actual space is operating.
So you mentioned the automation engineers, or what was the title that you used for those automation folks?
The ATC, so the temperature control contractor.
Right. So someone like that, based on your experience, what kind of background would somebody like that have, given the type of work that they need to do? Would having an architectural engineering background be beneficial to that person?
Sure. So typically what you'll see in that realm is they'll come from two different backgrounds. One will typically be from the HVAC community, and then the other one will be from the component community. And you'll see that they'll learn the other component while on the job. The component industry obviously is building the physical controller, so you'll see a lot of people with electrical engineering degrees. But then on the HVAC side, you'll have someone who's actually done the design and understands how the pieces of HVAC equipment work. So they're both valuable. So what you'll see at times is someone with an HVAC degree move into controls and learn the component side and how to physically build and design a controller. And then you'll have someone who's on the component side then learn how a chiller or air handling or a boiler, how they physically operate, so then they could build an appropriate controller to meet the sequence of that piece of equipment.
What would you recommend for someone starting out who may have an interest in the whole world of architectural engineering? They want to get involved in, as you say, making someone's dream a reality, building or maintaining these advanced buildings of the future. What are some of the skill sets, keeping in mind, the different aspects that these advanced buildings have? What are some of the skill sets you would recommend for someone, a young engineer starting out, or more to the point, so as someone's getting ready for their undergraduate studies, what sort of classes, what sort of things should they be looking to take?
Sure. So this might sound very, very simple, but one of the biggest characteristics I would say that is needed is for someone who is curious and someone who wants to be a problem solver. Mm-hmm. That is really what you're doing at the end of the day. It's a different problem depending on the type of building that you're dealing with, but at the end of the day, it's that curiosity of how things work and how things are brought together. So having those two characteristics are, I think, fundamental. Other things that they should definitely work on is their ability to work within teams, and most importantly, their ability to present high, complex, technical aspects in layman's terms. One of the things that you're going to realize as you're an engineer and you're working in the workforce, your audience is going to continually change. As we were talking about before, there's some owners who are very educated and very knowledgeable in the construction process. Others are not. So you have to have the ability to explain to various types of audiences the same type of concept. And you don't want to have a situation where you're using such technical terms as going over people's heads. At the end of the day, the owner has to feel comfortable with respect to what they're getting and what type of system they're going to get. And the way you make them feel comfortable is give them the ability to truly understand what they're getting. With respect to classes, I would recommend looking, especially since you're talking about going into the construction side. There are actually a number of architectural engineering programs now that are cropping up across the country. Penn State is known, Kansas State is known. If you aren't going to one of those programs, within the mechanical engineering department, they do have HVAC classes that you can take, so I would recommend those. Another thing that I would definitely recommend is with the internet, there are so many different free publications that you can take advantage of. One of the societies that you should definitely look at would be ASHRAE, where that is one of the paramount societies for HVAC engineers, and you'll have the ability to meet other HVAC engineers and go to different seminars and conferences to get a better feel for what is changing within the industry. And then I would say probably the next most important thing is to get an internship. At this point, if you're in your undergrad, you have an idea of what we do, but you really haven't done it yet. And one of the best experiences is to actually get an internship and dive right into what we actually do on a daily basis, because you may find that it's not what you thought it was, and you may want to, at that point, change your major. So I would always recommend that a young student get an internship as early as possible so they get a feel for the actual business.
Who are the major players in that area that you think would be good sources for internships or good places to at least look?
Sure. So, with respect to the internships, almost every college has a career fair. So when you go to the career fairs, especially at the AE career fairs, you will see consulting engineers there, and all those consulting engineers are looking for various types of engineers: mechanical, electrical, plumbing engineers. Every major city has consulting engineers that produce MEP and control systems for buildings. So a simple Google search or a LinkedIn search will give you a vast number of companies in the tri-state area, in the DC area, across the country, and across the world.
Got you. Basir, did you have any follow-up for Damian before we...
No, great answers to all that, and I think definitely a valuable experience and opportunities for experience that you're sharing with our listeners.
Yeah. Oh, thank you for your time, and thank you for the invitation again.
No problem at all. So, Damian, thank you again, and we look forward to hopefully having you on a future episode.
Oh, that would be great.
Awesome. And we are back. We want to thank Mr. Damian Payne for just one heck of a conversation. Basir, once again, we are so lucky to be getting such great guests. And once again, another guest hit it out the park.
Oh, yeah. Awesome discussion.
So, without further ado, we want to get into what we call our 3 takeaways from the episode. These are the 3 main points, the 3 main areas that we feel are the most important from this podcast. And we encourage you to do further research or investigation into these 3 areas. Really, the entire podcast was valuable and lots of great information. So it's always hard to narrow it down to 3 main points, but that's what we try to do at the end of each of these podcasts, give you our 3 main takeaways of the episode. First takeaway, as mentioned in the introduction, and hopefully you understood from the information Damian provided, that as the requirements for our buildings and homes, as the requirements for these homes and buildings to be more energy efficient, right? Requirements from the government, monetarily, requirements for money saving reasons and just conservation reasons. As these requirements become more and more stringent, there will be an increase. We're going to continue to see this increase. That's going to drive the increase in building automation systems. It's going to drive the increase in being able to have buildings that can smartly adapt their energy profiles and maintain energy efficiency in the way that they operate. So the various temperature control systems, everything, anything that requires electrical energy, anything that requires resources to heat or cool the building, all these things will be or are now going to be more smartly controlled and automated through the internet, through networks, through data networks.
Absolutely. And I think that brings us into our second takeaway. With all of these savings and opportunities, how do you find them, or how are they categorized? And Damian mentioned one certification. He mentioned several certifications. Damian's very well qualified. One of the ones I wanted to highlight was the LEED certification. And I hope all of our listeners go out there, take a look at that, and just know the LEED certification in terms of a standard for building. LEED certified buildings are among the top 11 percentile in energy savings. If you go LEED Platinum compared to no LEED at all, you're looking at potentially a 60% reduction in your energy usage. That's huge. When you're starting a building or you're modifying a building, that you could potentially save that much. That's very important, not only on a personal level, but in terms of opportunities for the future. There's so many companies that will be looking to hire someone who might have that knowledge and can utilize that knowledge to in turn help them save money in some type of building design or construction or remodeling. Yeah.
And again, LEED, for those who missed when Damian explained the acronym, or outlined what the acronym is, it's Leadership in Energy and Environmental Design. So the name says it all. And as we seek to be better stewards of the environment, the LEED certification, will be very, very, it'll just continue to increase in importance. I want to thank everyone for joining us this week. Basir, thank you so much. Any closing remarks or comments?
No, just keep looking out for things. Keep looking out for more podcasts. Take a look. Please let this be the beginning of your journey.
Absolutely. And again, questions, comments, please contact us at stembros@gmail.com. That's STEMBROS@gmail.com. Thank you for joining us. Thank you for the time. And we look forward to seeing you or having you join us for the next installment of the STEM Brothers podcast. We are gone.